Okay, today we'll see the subject called as cloning. So cloning is also a concept now in Java. Okay, so first let's understand what is cloning, and then let's see how Java supports cloning now. Understood? So always we have to learn concepts now. Okay, and when you require that, Java gives the support from its library, nothing else. So let's understand the concept of cloning and how Java supports is a very simple matter now. So I'll have one class called as hello now. Okay, and I'll have some variables, int a, int b in it. I'll have one constructor, int a, int b, are the two variables. And that's it, you have got a class now, and it has got two instance variables. And I can create an object of this now. This will be your class, hello, and I'll have a class called as demo with the main method. And I'll say hello h1 is equal to new hello, and I'll pass the values 10 and 20. So what happens now? An object of hello is created, and it has the values as what? A as 10, B as 20. Valid now? Yes or no? So this is how the object will be created now. Okay. So if I want to do cloning now, what is actually cloning? Definition. Cloning is a process of creating, see, it's a process. It is a process of creating a duplicate copy of an object. It is a process of creating a duplicate copy of an object. That's what actually cloning means. That's the concept now. Okay, I want to implement it. Now how do you do the cloning, you tell now? Means you have to create one more object, okay, which is duplicate as this. How will you do it now? Huh? And I need the same values. See, when I create the object, the state of the object, both the objects should be same now. So you have to say hello h2 is equal to new hello, then 1020. You will never know the values, they will be dynamic. The values will be dynamic. So you have to create a duplicate object or a cloned object, we find this difficulty now. Understood? So anyway, we can't do it. So how will I do it? See this. I can tell this now. First I'll get the value h1 dot a int x is equal to h1 dot a, int y is equal to h1 dot b. I'll get the values. Then I'll say what? Hello h2 is equal to new hello of x comma y. Simple. Understood? So now h2 object will get created, which will have the values of which one? A means you are sending x and y. What will be? So the constructor gets executed in h2 now. So you'll be having the constructor here. So yes, the same object gets created. It's not an issue now. Fine. So this is what is cloning now, and that's a different object. This is a different object. Both are different objects. This is h1 and this is h2, and they are different objects. Both are having different addresses. Their addresses will be different. So this is what you do now. Understood? Now supposing I will have one more object. Hello h3 is equal to new hello. Okay, and values will be something like 11 and 22. So one more new object it is. So I want to create a clone of h3 object now. Again, what you have to do? Same process you have to take now. I want to create a clone of this one, means h3. Hello h4 is equal to new hello of. Directly you can write h3 dot a comma. This way also you can write instead of accepting and doing it. For now h3 and h4, two objects will be created. First h3 will be created, and now you are creating a clone of h3. So value of this is 11, 22. If I create h3, a clone of h3, this will also have the same values. So h4 is a clone of h3, h2 is a clone of h1, like this. Understood? So this is what you mean, creating a duplicate copy of an object. Understood? So fine, see, this is all is okay, but what you have not observed is, what if by chance these variables are private now? How will you do the cloning? If you can access the value, then you can do cloning. So we start facing problems now. Understood? If I have my member as private, now almost all you cannot access it. How will you get the value now? Only if you get the value, then you can provide it to what? H2. If I get the value of H1, if I can access the value of H1, then I can provide the same value to H2. Similarly, if I can access the value of H3, then I can provide the value to H4. Like this, complications will start off. So Java gives you a very simple approach for all this now. Okay. So and we do it with the help of an interface called as Cloneable now. So for doing cloning, we use an interface called as Cloneable. Okay, for doing cloning, let's see. These are various problems you will face now. Okay, and let's see, concept of cloning you understood now. And in this concept of cloning, what is the problem? Developer is doing the cloning now. We are writing the code for doing what now? That is one headache. We don't want to write any code. We want all the support from where now? Library. Because if there are 2 variables, I will do the cloning. What if this class is having 10 instance variables, 20 instance variables? So cloning becomes that much difficult only. If this class is having 2 variables, I will take the 2 variables and I initially create one more object. But if this class was having 10 or 20 variables, cloning would have been really difficult now. That would have been difficult. Second thing, members can be private. Third thing, I don't want to write the code. Means we developers don't want to write the code. We want the support from the library. That's how Java is built. So in Java always we expect the support from the library. So like this 3-4 problems we start facing. You got the problems now. Variables might be private, then too many variables might be there. Another problem is, we don't want to write the logic, we expect the support from library. Yes. Who is going to give the support to you now? An interface called as Cloneable. And this is a very interesting interface now. We are going to study this. This interface looks something like this. This does not have any members. Generally till now what you have studied, an interface contains what? An interface can contain only 2 types of members. One is public static final variables and the other one is abstract methods. Apart from these 2 it cannot contain anything. But this interface will not even contain those 2 also. And this is the first time you are coming across this kind of interfaces. And an interface which does not have any member is called as what? A marker interface. A very new introduction. Okay, so definitely asked in interviews. Okay, what is a marker interface? An interface which does not have any members is called as marker interface. Understood? So all you have to do is just do this much now. See, if I want the library support, I'll tell now. First step, implements Cloneable. So I'll use that. It's an interface, means you have to implement it. So fine. We are going to implement it. But when I'm implementing it, see, generally when you implement an interface, what is that you do? You override all the abstract methods present in that interface. Yes or no? Yes. But there are no methods. There are no methods present in what? Cloneable. So when there are no methods present in Cloneable, what happens now? I will not override anything now. I will not override. Fine. Okay. So you don't have to override any method present in, because there are no methods present now. So this what happens now if I do this? If you implement Cloneable, what happens? So this means we are now learning what is a marker interface. Okay. A marker interface, first point is it does not have any members. Next point is, if a class implements a marker interface, what happens? Okay, see, right, as from the developer point of view, nothing. But from the runtime point of view, a lot of things happen. If any class is implementing Cloneable, JVM itself will do the cloning now. It's an indicator. So marker interfaces act as indicators. It indicates, okay, this class is eligible for cloning. So if the JVM sees any class is implementing Cloneable, automatically it will only do the cloning. Means you don't have to write the code. Who is going to do the cloning now? JVM will do it. So marker interfaces act as indicators. If any class implements this, automatically it will get the cloning behavior. Understood now? So this is the first thing what you have to do. One more thing you have to do now. What you have to do is, so just I'll clear this now. Shall I clear all this what I have written? We'll see what we get the support from the library. So here I explained you the concept of cloning. Okay, now we are learning it, how to do it. So all you'll do is, Okay, you implement it, and we have seen one method called as clone. This method comes from where? Class object. This is the last method which is pending. We have covered all the methods of class object. One method which is pending in class object is clone method. Understood? Totally there are 11 methods. Okay, I'll revisit and show you. So one of the method which is present in class object is cloning. Okay. See, in fact, this clone method is present in the superclass. If you implement cloneable and call it now, automatically. See this. If I implement cloneable, I'll remove all this now. See, if I implement that, and say hello, h is equal to new hello, it is in superclass now. Definitely I can call it h dot clone. It should be cloned now. But the problem is the clone method in class object is protected. The clone method in class object is protected. So you cannot see, you cannot access a protected member in another package outside the class. Protected members can be accessed where? Only in subclasses outside the package. See, this is the story now. Java.lang.object. This is the class. Yes or no? Now, our class is there, hello, which is a subclass of what? Object. But this is there in com.cluster package. Valid. So you are having your members, agreed. But now, the member of object, where are you accessing? In demo class. So demo is a different class. Yes or no? So you cannot access a protected member. See, this is a protected member. Clone is a protected member of object. So how can I access a protected member in class demo? It is not possible. But the same clone method can be accessed where? In hello class. Clone method can be accessed in hello class. But clone method cannot be accessed in demo class. Why clone is accessible in hello class? Because it's a subclass. Protected members are always accessible in subclass outside the package. I can access it here, but not there. So that is the problem. That is why what I'll do, I'll override. So once I override, what I'll do, and when I override, in this method only I'll call the superclass method. And I'm making this overridden method as what? Public. So once I make this overridden method as public, I'll just invoke it. I want to invoke the superclass method. How will I invoke the superclass method? I can call clone. But the problem is it becomes recursive. So all I'll do is super.clone. That's it. Cloning means, and the return type of clone is object. I'm sorry about that. So return type of this would be what? Object E. 1 second. Object E is equal to super.clone. Return E. That's it. See, only thing, since we can't call it directly, what I did is I'm overriding, and in this overridden method I'm only calling that. That's all I'm doing. More than that I'm not doing anything. Understood? So that's it. h.clone means what is the return type? Object, superclass. But if I want to access a subclass member, what I should do? Typecast. So either you can write like this and do the typecasting, or you can do it in hello h1, this is hello h2 is equal to hello of E. Do like this in 2 lines, or directly say what? h1 dot clone hello h2 is equal to over. You are actually invoking this method. That's it. Now you are invoking this method. Now you are clear with this now? I am invoking this. So this will invoke the superclass. Since I can't directly invoke that clone method of superclass, I'll take this route. That's it. Now I could have written this. See, if you don't want to write clone like this now, you could have written it like this: public object m1 method. Here I could have done what? Object E is equal to, directly I can call the superclass method. This is another approach if you don't override. Understood? And you can say what? Return E. This is also valid. So that time for cloning, which method you will call? h1 dot m1. Same it is. So return type would be what? Hello h2 is equal to hello of. This is also valid. But the problem is in one class, if you use one method for cloning, the developers will not be comfortable. So we have some standards, like for checking equality we override equals method. Then for clearing the resources we use finalize method. Similarly for cloning also we have one standard, we go with clone method only. So I can use other methods, m1, m2, any method I can use. If you use m1 and m2, no need of calling super.clone. Directly I can call what? Clone. Clone is a method of superclass, you can access it in subclass. Directly you can call it like this. This is one option. Okay. But since this m1, m2 and method and all are very confusing for others to use, because how will other people know? See, you have written your class. Now how does the other person know which method is doing cloning? So it becomes a headache. So that's why we follow standards. So what we do, we override and make it as public method. After making it as public, what we do? We invoke the superclass method. That's the thing what we do. That's it. But did we write any logic? No. So the clone method of superclass object now will do the cloning for us. Are you clear with this now? So both are correct. I would recommend always do cloning in what style? Not this. Even though this works, don't do this. Do this. Because it's a standard. Understood? The recommendation is standard. Yeah? Both are correct. So only here what happens is I am overriding and calling the superclass method. When you don't override, directly you can call now. So you know how to use super. Super is used for what? Accessing the members of superclass. I am doing it. That's it. Are you clear? Okay. So I'll go with this example only. I'll clear this now. Yeah, let's see what happens now. So let's see this now. Hello h1 is equal to new hello. What happens? An object of hello is created. Sorry, I had not given any values now. 10 and 20. So I create an object of hello. So A and B will be having what values? 10 and 20. Next, I'll say h2.clone. Where is the clone method called now? From your class. I'm calling the public method. In turn, what will this do? Call the clone method of superclass object. This is a member of class object. This is a member of hello class. So I called this. This will in turn call what? The superclass method. Now automatically this clone will do what? Cloning. It will only do the cloning. Understood? And it will create a duplicate object with the same values. Now, why do you worry? Understood? Same thing it will have. It will also have clone, all the same things. It's one more object now, that's it. H2. Same members it will have. Done? Finished. Now you can access, you can work with H2 also. With H2 you can access what? All the members. It's a duplicate copy. But that is a different object, this is a different object. And they are independent objects now. Okay. 150 address, 250 address. So you can print the address and see also. It will be completely different. Clear this now? So this is what is cloning. So for doing cloning, what did I do? Simple. First step is you have to implement cloneable, a marker interface. That's it. Override clone, and that's it. Call the superclass method here. That's it. Only one line of code you are writing. Means we enabled cloning in the object. See, by default all objects are not clonable. By default all objects are not clonable. That is why they are making the method as protected. Otherwise what would happen if the object is not protected, if the method was not protected, you can call it directly now. Now all objects will be eligible for what? Cloning. So Java did not want all objects to be eligible for cloning. They are telling if you want cloning, then you enable it. Understood? For enabling what you have to do? You have to implement clonable and override clone. Only two steps you have to do. That's it. Understood? And this clone method of superclass, actually there's one last thing what you have to do, throws an exception. Okay, so it throws clone not supported exception. Just write throws clone not supported exception. We have to write it in full. Throws clone not supported exception, because this throws and it's a checked exception. Either you write try catch here or write throws. So you have to catch where now? In main method. So in main you write try catch clone not supported exception. That's it. You have to write it fully. Clone not supported exception. I show you the code, you'll understand this. That's one last thing what you have to do. Done? So let's see the code only. Should I clear all this now what I have written? So this is cloning, a very interesting subject, and Java gives you beautiful solutions for all your problems now. And you got the idea now why they made clone method as protected. They don't want you to simply call clone. Directly try to call it. No, it will not be possible. So let's see and see the examples for cloning have been kept in D drive. Eclipse examples, August 2013, same almost Ravi Kumar. Java examples, I have kept it here, organized it here. You can organize it in your own style. So here I have got cloning. So these are the three examples what you'll be seeing now. Okay, so the first example what you are seeing is this one, and the heading again is shallow cloning. Yes, this is the same thing what we are talking now. See, class hello implements cloneable. Return super.clone, that's it. Nothing more you are doing. Understood? So let's go to the docs, see what is happening here. Java.lang.object, because that's a method present in class object. Yes, you can see I have covered all the methods except clone. Equals I have covered, finalize I have covered, get class I have covered, hash code I have covered, notify all, toString, wait, all these methods I have covered. One method which is left pending is clone, so that completes class object. Okay, so these methods are available to all your classes and you should know how to use it. So that is why class object is the super class of all classes. Some common functionality is needed for many classes. So that's why they made it. Anyway, so this is one part, leave it. So we are going clone method now. And if I click on this, okay, let's one second. What does it do? Creates and returns a copy of this object. It's very clearly telling you. Okay, creates and returns a copy of this object. And it throws clone not supported exception. And it is a checked exception. Understood? So let's do cloning now first. See, by chance, if I don't override and try to call it, I'll get an error. Reason is protected member. How can you access a protected member in a different class and different package? Understood? So it is not possible. You get the error. The clone method from type object means from the class object is not visible. So but I can access it in subclass. Yes, that's what I am doing. Definitely I can access it in subclass. So when I do it, you can write it in a single line like this shortcut, or you can write in a big way. Object is equal to super dot clone return. You can write it in two lines also. But we generally go with shortcuts. The meaning I explained to you, what is return super dot clone if you're not understanding. Both are valid. Understood? So fine. So it throws what now? Because it's a checked exception. See, if I write only this much and don't do this, it says give me an error. Why it gives me an error? Unhandled exception, and it's a checked. So you're either forced to write try catch inside your method or write what? Throws. So I'll write throws. Done. So once I do it, yes, here also I have to write try catch. Now if you don't write, what will happen? See, if I don't write here, when you call that method, that exception is coming to this method. So what do you have to do? Again you have to write try catch or write throws. Public static void main throws you have to write. So anyway, so we'll just go with try catch. Yes, problem solved. That's it. Okay, and now say I'll do the cloning. I'm creating an object. Check this of h1. Then what is that I'm doing? h1 dot clone. What is the return type? h2. Fine. Now look at the addresses. h1. I'm printing h1. Why am I printing h1? To print the address. h2 also will print the address. You can see definitely there will be different addresses, but the values in both the object will be same because we are doing cloning. See this now. Even though the two different objects here, okay, values are same. And remember one point now, when you do cloning, understood, in the when the cloned object is getting created, their constructor will not execute. Constructor is never executed when the cloned object is getting created. Directly values will be copied from one object to another object. That's why you can see I have printed on SOP inside constructor here. In the constructor of hello class I have written simply an SOP. Why did I write it? So to show you that the constructor is executed only once. So this is a program now. This is the class. This is the clone method. Fine. And this is your code now. Hardly I have written these many lines. Cloning is implicitly happening for you. Understood? So now what happens when you say hello h1 is equal to new hello? When h1 object is created, it will have a and b, values will be 10 and 20. When you say h2.clone, that's it. Automatically the clone method, see your clone method is getting invoked. This clone method will invoke what? Super.clone. This clone method is invoking super.clone method. What will super.clone method do? Class object, simply it will copy the values. Blindly it will copy. So here the constructor is never executed in h2 now. Understood? So it will copy the value straight away into this h2 object. So when the h2 object is getting created, constructor is never invoked. So simply it will copy. What value is there in A, it will copy into A. What value is there, blindly it will copy. And who is doing that? They have written already the logic for you. They have already written the logic for you. Okay, and it will happen. But this is possible only if your class implements clonable. Otherwise, it is not eligible for cloning. You might write all the logic. Okay, by chance, if I don't implement clonable, now the story starts. Everything is perfect, no compilation errors. Getting it now? See, there is no compilation error. Perfect it is. Okay. So, clone not supported exception. The exception gets created. Okay, here when you are trying to call the clone method, now when you are calling super.clone, you will call it. See, you are calling clone. This clone will call what? This one, super class one. So, in this clone method of class object is getting called, it will check, is the class implementing clonable? No. So then it will not do the cloning and it throws an exception. Exception will be thrown, it comes to your code now. Because you are saying throws. It will come here and I am catching it here. If I had not caught it, I would have gone to the JVM. So this is how it goes on explaining. So it inside exception and it prints it. Yeah? Okay. So now the marker interfaces. What are marker interfaces? Now they act as indicators. Only if you implement it, then only it will be eligible for cloning. Even though it does not contain any methods, it's an indicator. Understood? It's an indicator. Like this, more marker interfaces you will start seeing. Okay. In the next class, you'll be seeing one more marker interface like serializable. So when your class implements serializable, you'll get some other behavior. Understood? So if the class is implementing clonable now, the class will get what now? Cloning behavior. Similarly, there are more marker interfaces. One more is example serializable. If you implement serializable, the class will get some other behavior. Okay, one more marker interface is there, remote. Okay, if you implement that, some other behavior you will get. Understood? So a class which implements a particular marker interface now, it will get that particular kind of behavior. Okay, so this one concept what is new to you and you'll be understanding it slowly. Okay, so just so to highlight now some points on marker interface. First learn what is a marker interface, and you see more marker interfaces, this concept will become, you understood this now. Okay, but more marker interfaces you see, more clear it will become. That's it. Understood? So marker interface is used to provide what? Indication to the JVM so that it can add special behavior to the class implementing it at runtime. So if you implement clonable, what is the special behavior you'll get? Cloning behavior. Understood? So that's how. If you implement serializable, some other behavior you'll get. If you implement remote, you'll get some other behavior like that. Understood? So a marker interface does not have any members. Remember this. And till 1.4 they were releasing marker interfaces. But after the release of annotations in Java 1.5, Java has stopped releasing marker interfaces and we use annotations now. This one point just understand, gradually you'll understand now. Okay, so from now on you'll not see more of marker interfaces released by Sun. You'll be seeing more of annotations. So just one point to understand now, this is where the annotation subject will start off. You'll now understand why annotation was introduced in the language. Okay, so after introduction of annotation in Java 5 version, annotation is better choice than marker interfaces. And some of the examples for marker interface are these four. Very, very, very important interview question. What is marker interface? Is a very, very, very important interview question. Definitely asked. If you are 1+, 2+, 3+, 4+ also, It's an interview question. Understood? Now see, first question will be what is an interface? You will tell interface is a user defined data type and it does not contain any concrete methods. It contains abstract, all that you will tell, abstract methods and all that. But why do you use why do you use an interface? Interfaces are used for what? Setting standards or setting specifications to decouple declaration and implementation. You know all this. Okay, so that is different. But marker interfaces, they do not contain anything, but they act as indicators. They indicate something. Okay, only if the class implements that, then it will get that particular behavior. But it will not contain any members. Understood? So this is what is marker interface. You should know the difference, and it is extensively asked in interviews. Okay, this is the first one. You see more, you will get clear idea about this. Basically you understand this much now. Or it is also known as one more word, tagged interface. Marker interfaces are also known as tag. You are tagging it. It's something like you are setting a flag on the class. Okay, and if the JMC is, if this class is implementing Cloneable, definitely it will do the cloning. Else it will not do. Just now I showed you. Understood? So it gets the cloning behavior. So if you get this concept of cloning, now other concepts are very simple. Understood now? So hardly we are writing any code now. The support comes from the library where it is in the clone method of class object. Done? This is the first example. Next, very interesting things in cloning now. Yeah, now the story becomes interesting. Say I got a class test, one more class, same story now, class test. Understood? Now class test, it is having how many variables? Int x and y. Fine, that is okay. But it has been used as an instance variable in hello class. It is having what relation? Has a relationship. So class hello has a test. So it's having has a relation. Now it becomes very interesting. Let's see how cloning happens now. Can you guess how cloning will happen now? Everything same. I'm trying to clone what now? Hello object. So first see, we'll go to the code straight away. I'm saying test t is equal to new test. So what happens first? Test object is created. What are the members of test? 11 and 22. Agreed. This is t object. Any questions here? No. First. So why did I create the test object first? Because that is used in the constructor of what? Hello. See the constructor of hello? So this constructor needs 3 arguments. 2 int and 1 of type test. So that's why first I have to create test object, then I'll create hello object. So when I'm creating the hello object, next what I'll do, I'll send this as an argument. So hello object gets created now. This is h1. This might have some address 150 or something, or I'll write as 555, some address it will have. This will have one different address, 150. Fine. So in h1 now, the instance variables are what? A and B, same. And the value of A is 10, B is 20, and there is an instance variable of type what? Test. These two are int. But this is of type test t. Okay, these two are also int. This is object of test, this is object of hello. Done? So t will refer to this one, yes or no? Because I am giving the reference now. It's very clear. Fine. So we have created the object now. Do you have any questions till this line? I have created 2 objects. Has a relationship now. And this has a relationship, we have created 2 objects. I will call clone now. So what does clone method do? You know very well. Blindly what it will do, it will create one more object. See, clone has been overridden. Where it has been overridden? Hello class. Same code, clone has been overridden. There is no change in the code. It is implementing Cloneable. I am calling the clone. Everything is perfect. So all I will do is what now? All I will do is call the clone. So clone object is getting created. Same process. Okay, the clone method of superclass executes. One more new object is created. Here also I am having the instance variables in h2. So what does it do now? Can you guess? blindly it will copy the values, same values it will copy. But this time in our object, hello object, we are having an reference variable. So what value is there in t, same value is copied, and this t also will refer to the same object. Understood? No? This t also will refer to what? So the t in h1 and the t in h2 both are referring to what? The same test object. And if I print h1.t, it will print what? Same address. h2.t also, it will print the same address. And one more thing, if I change h1.t is equal to dot x is equal to 99, it will affect this also. So you should be careful while cloning. Means you should be extremely cautious while cloning when you are having your instance variable as user defined type. Understood? First see the output. This is the major thing now. See here. That's what the same code I have done. I'll print h1, I'll print h2. Okay, it prints different addresses. h1 is a different object, h2 is a different object, valid. But h1.t and h2.t will be what? Same address. Understood? Next, I'll print the value of x before modification. I'm going to modify. So what will it print? h1.t.x is 11. Initially it will be 11. First time when I created the object, see it is having a value of 11. But when I modify, in h1.t.x it is 99. From x 11 it will be overwritten to what? 99. So before modification it will be 11. After modification in both objects h1.t.x and h2.t.x it will be 99. Problem now. Okay, let's see the output you see first, then we'll see how we get the solution for this. Same thing what I told you now is getting done here. Constructor is executed only once for the first object. Cloned object, no constructor, yes. So see, first I created the test object. This is the address, SOPT. What is the address? It is printing test at the rate of something like this. Next I am creating H1 object. Next I am creating H1 object. So that address is this one. Then I am printing, see, 1 second. Yeah, so now we are printing h1. So h1 dot, okay, two objects have been created, what I said, yeah, test object finished, created the h1 object, h1 dot clone, return type is what? h2. So HOPT it's printing on address of which one? Test. h1 what it is printing? A different address. h2 is different, notice. h2 is different. Both are h1 and h2 are different addresses. But the story is in h1 and h2 now. h1.t and h2.t are printing what? Same address. So carefully notice. So the t is same. Means that clearly shows that both are referring to the same object. And that is why before modification the value will be 11 and once you change it, it will be 99. So it is getting affected. And fact is, when you do cloning, what expectation we do have is, okay, the exact cloning what I want is, h1 should have his own copy of t object, h2 should have its own copy of t object. This is my requirement now. My requirement is this, I don't want this to happen. This is cloning because if you change it somewhere here, no, it should not affect the other object. Understood? So how do you do this now? Anyway, this concept what you saw now till now is called as shallow cloning. Shallow cloning, what it will do? Directly it will copy the values from one object into there are two types of cloning in Java. One is shallow cloning and the other one is deep cloning. And shallow cloning, you can depend on shallow cloning when you are having primitive variables as your instance variables. If you are having primitive variables as so do it. You should do shallow cloning when you have primitive variables. Primitive variables means which one? Int, float and all that. There it doesn't make any difference. You're having primitive variables as IV, instance variables. Do which one? Prefer shallow cloning. It doesn't make any difference. Understood? Supposingly See, if I make a h1 dot a change, will it affect in h2 dot a? No, it will not affect. If I say h1 dot a is equal to 100, will it change in h2 dot a? Understood? So primitive variables will never change. So you can always rely on shallow cloning when you are having primitive variables. But depend on deep cloning when you are having reference variables as IV, instance variables. I don't have space, that's why I'm writing IV, instance variables. Understood now? So this is the concept now. I'll show you how to do it. Very simple, nothing big. Okay, we'll see it in the next program. Are you clear with this now? So the next concept is how to do deep cloning. Should I clear all this now? Same diagram now. What will happen? Diagram will be same. Only how you, diagram will be same means what the changed one. The new diagram what I have written now. H1 will be referring to this copy of test. H2 will be referring to this copy of test. How it happens? So for that you have to do the third example I am going now. It is called as deep cloning. Same, hello class doesn't change. Only one thing what changes is the test is implementing Cloneable now. That's it. Earlier test I'll show you what happened. Small differences. So in shallow cloning what did you do? The previous example, test was not implementing Cloneable. Test was not implementing Cloneable. So when I want to do deep cloning, what will I do? Test implements Cloneable, fine. Everything remains same in class hello, only one line changes. What do you do? Instead of directly returning super.clone, I'll call super.clone. I'll typecast it. But in h.t, what will I do? How I am initializing t now? I'll call t.clone. I'm calling the clone method in what? Test object. So test object, new test object gets created. Automatically what happens? The reference of that is given to h.t. Okay. In a while I'll explain this to you, but see this. Actually what happens is, see when I call this clone method h1.clone, same object, here we have the clone method, what it is doing now right now is, hello h is equal to hello of super dot clone, you'll call this, and then I'm saying what, h dot t is equal to test of that's all, and you'll return h. So when you call h1 dot clone, first same object will be created ditto to ditto, and t will be referring to what? Same object. So this is in the first line, this will happen, hello h is equal to hello of super dot clone. When I say, same thing will happen. But one more line extra I have written. What I am doing? H dot t means this t I will initialize with what now? In the new object. T dot clone, we will call the clone method. Okay, so on which one? Test. So that address, one new object will be get created now. So that address I am overwriting. First t was referring to this, now t will refer to this. That's it. Only do this much, automatically what happens? You will get two separate objects. That's all you have to do. Nothing more. Just follow the code, concept I explained to you. Okay, go through the concept now. So that's what is cloning now. So you do deep cloning. And when do you do deep cloning? When you are having instance variables as reference variables. That's it. Very simple concept it is. Just initialize the reference variable. Just initialize the reference variable again. How will you initialize it? Like this. Don't bother about super.clone will initialize the primitive values. But t.clone why I am calling? So that I reinitialize t here. That's it. So let's see the output. So you're seeing deep cloning, everything remains same, only that 2 lines of code I have added extra, which are this code, and I made a test as cloneable. I made test class also as cloneable. That's it. Means it is a chain now. If test is cloneable, then hello becomes cloneable. Means deep cloning will happen now. Because hello is depending on what? Test. Hello is depending on test. So if this is cloneable, then only what will happen? If both are cloneable, then only you'll get object like this. But if only one is clonable, you'll get only that object as cloned, and this will not be cloned. So if you want both to be cloned, better you implement clonable for both. So that's a simple concept. See here. Test T is equal to new test 11 comma 22. First, which object is created? Test object. What are the values? Same code, hardly any change. 11 22. Then I'll create the hello object. Hello T is referring to this one now. I'll call h1.clone. One duplicate object is created. Once the duplicate object is created, in this duplicate object T will be referring to initially to what? Same one. So what I'll do? I'll change it now. h.t is equal to something. So automatically this T will refer to this one now. So that's it. After that you print T address. This address it will print. Now h1 completely different address. h2 completely different address. That you know. h1.t, yes, it will print this address. But h2.t different address. I'll modify anything here. h1.t.x is equal to 99. But h2.t.x will be 11 only. See the output. If you see the output, h1.t.x will be first anyway both will be having what? 11 and 11. But once I modify it, in h1 t will be having x as 99, in h2 t will be having value of x as 11 only. What are the old value? So you have to study this now. So first the test object, the first one what we print. Yeah, this is the first one. T is printing that address. Then we are printing h1 and h. So first I create the hello object, then I am calling clone. Once you call clone and print T is having this address. h1 is having this address, h2 is having this address. Now h1.t and h2.t, check this out, this is very interesting now. h1.t and h2.t. h1.t prints a different test address, h2.2 prints a different address. And the value in h.t before modification 1111. But once you update it in h1 it is changed to 99, but in this one it remains same. So this is the concept of deep cloning. So always do deep cloning when you are having instance variables of type reference variables or user defined. That's it. Understood? That's all the concept of cloning. Okay, there are two types of cloning and you should know when to do which one. Otherwise you'll have some adverse effects like that. If something is modified in one object, it will affect the other object, which we do not want. Understood? Here you might think what is the big deal? But imagine now in class hello. Int A, int B, okay, I am using this too. But if I am having file input stream as an instance variable, file input stream fin, so okay, fine. Then I'll call clone. Okay, see, after calling clone, h1.clone, there are two objects now. Hello, h1 is equal to new hello. Once I call clone, okay, I'll get hello h2, do the typecasting and all that. But now see, h1 dot fin dot close means what happens? The resource is closed for h2 also now. So this is where it becomes more complicated. If you close the resource in one object, automatically it will close in another object, no? So this becomes a terrific hit to your application. So be careful when you do cloning. Understood? Fact is we never do cloning in projects, but this is one of the most important interview question. Okay, that is why I have just put this. In real life applications, very rarely we do it. And where cloning is really required, Java has already implemented the logic. For which classes? Date class, calendar class. All your collection classes are implementing what? Cloneable. Array list, linked list. Where cloning is required, they have only done it. We hardly write any logic for cloning. But this one concept called as cloning, and this is how Java supports it for you. And this is the reason you should be extremely cautious when you do cloning. Understood now? So instead of test, think this as fin object now. And h1.fin.close means this resource is gone now. So obviously this other object also cannot use the resource. Done? Okay. So these were the examples. 3 examples I have given you. 2 for shallow cloning, one for deep cloning. That's it. So we do not write any logic in Java, remember that. Understood? Everything is there in the library. Only you should know how to use the support. And examples, see, what I have done is only 3 examples are there, but I kept it in 3 separate projects for you. First one is 0 and shallow cloning, okay, which talks about primitive variables cloning. Okay, this is the first one. This one which you saw, shallow cloning. Nothing is there, just what? Primitive variables. In the second example is there in the second project. There we are having user defined data type. And third one I am showing you same user defined, same example but with deep cloning. Only 3 examples, 3 projects. Done? Why I created 3 projects? Because I am using the same class names now. So conflicts will occur, so that's why I have created 3 projects. Fine, done. So that's it. So now next, let's see the notes for it. So interface, clonable and cloning now. So what is cloning? I had already told you. Cloning is a process of creating a duplicate copy of an object. Understood? Only classes that implement clonable interfaces can be cloned. Remember that. Otherwise, JVM will not do cloning. If you try to clone a class that does not implement clonable interface, clone not supported exception is thrown. Very important interrogation. When do you get clone not supported exception? Understood? Fine. Now, when a clone object is getting created, the constructor is not called for that object. Understood? Next, some of the built-in classes which implement clonable interfaces are date, calendar, all collection classes like linked list, array list. You have already seen one point, always in collections you are seeing it. Both are clonable, both are clonable. So we have seen all the collections are clonable, that's the point now. Fine. Means that's why you are able to call al.clone, treeset.clone. You can call it, directly you'll get what? One more object created with the same values. Okay, fine. Next, following are the rules to do cloning. These rules you should remember. What rules? To clone object of any class, the class must implement what? Clonable marker interface, otherwise this will be thrown, and you have to use the clone method which is present in class object. You have to use it. Now, how you use it? Better is you override and call that superclass method. That's it. Because directly you can't invoke it. Then next, there are 2 types of cloning, shallow cloning and deep cloning. That's right. We have to do shallow cloning when object to be cloned is having primitive variables as instance variables. By default, clone method in class object is doing shallow cloning. Directly it will copy as it is. Understood? Then next, we have to do deep cloning when object to be cloned is having reference variables as instance variables. That's it. Last part. What is interface clonable? It is a marker interface and does not contain any members. It should be implemented where for classes where cloning is required. Real time, practical time, very rarely use it. Okay. Programming wise, only from the interview point of view, little you should be aware of this. Only from the interview point of view. Okay. So what is cloning, what is deep cloning, shallow cloning, that idea if you have, that's more than sufficient. Clear? Now why it becomes important in interview? Reason is because clonable is a marker interface. That is why it becomes important in the interview. They ask what is marker interface and give some examples. So that's when it becomes important. When you give the example, automatically they'll ask you details about clonable interface. And this interface is present in what? Which package? Am I importing? So it's present in IO package. Sorry, lang package. Sorry, I'm sorry about that. It is present in lang package. At one point, you can add it. That's it. Yeah. So I think mark interface also we discussed. So that's all about cloning. That's it.